we're getting started. Phones away. 3.9 paper out. Computer closed. Chromebooks closed. Calculator out. Keith, close your Chromebook. Here we go. So guys, today we're going to talk about imaginary numbers. And we talked about in the beginning of the year that there were different types of numbers, and we did a PowerPoint. There are different types of numbers based on where they fall on the number line, okay? So your counting numbers or your natural numbers are 1 through 1, 2, 3, 4, 5, 6, up to infinity. If you add 0, then it's the whole numbers. So from here to here, that would be the whole numbers. If you add positives and negatives, that's the integers. If you have fractions, that's the rational. Okay? Now, irrational are what we worked with last time, where if you put them in the calculator, the decimal goes on forever. Okay? All of these, if you were to graph them, you could graph them on the number line. Okay, so 0, okay, that's a whole number. 5, okay, -2, 1/2, that's in the middle of 0 and 1, and even pi. Pi is irrational. The decimal goes on forever, but it's about 3.14, so 1, 2, 3, it's kind of in there, okay? We're going to talk about numbers that cannot be put on the number line, and those are called complex numbers or imaginary. Complex is all of the numbers. So far we've worked with these, okay? And now we're going to work with imaginary. And if you combine them, then all of them are called complex, okay? So it says for each expression, determine whether the sum is a rational or irrational number. For 3.8, all of our answers were irrational. They were like 3 plus or minus the square root of 5 over 2. And if you put that in your calculator, your decimal would have gone on forever, okay? So a rational number can be turned into a fraction. Irrational number, the decimal never ends or repeats. So for this first part, we're just going to see what happens. This one's a rational number because it's a fraction. This one's a rational number because it's a fraction. If I add the 2, go ahead and add the 2. Do 1/2. There we go. 1 divided by 2. So one rational number, one fraction. Plus the next one, 2 divided by 3. And I got a decimal that repeats. Ends or repeats. If I hit math, frac, it turned back into a fraction. 7, 6. If it can turn back into a fraction, it is rational. If you do it and it doesn't turn back into a fraction, so let's try this one. This one, the square root of 7, that is irrational. The square root of 7 does not simplify. So if you put the square root of 7 in your calculator, see the decimal goes on forever, it doesn't simplify. 1/3 is rational. It's a fraction. It ends, okay? It repeats, so it turns into a fraction. If you were to add the 2 of them, plus 1 divided by 3, that decimal doesn't ever end. No, it ends because it runs out of calculator space. Let's see if I can turn it into a fraction. It doesn't turn into a fraction, so this one was rational. The 2 of them together are 2.979 ... It is irrational. Okay, so all of these were real numbers. You can put them on the number line. Even if the decimal did not end or repeat, you can still put it on the number line. We're going to start talking about imaginary numbers. Imaginary number is any product of the form AI, in which A is a real number and I is the imaginary unit defined to be the square root of -1. Basically, you cannot have a negative square root. And here's why. Can you guys think of two numbers of the same numbers that multiply back together that can make a -25? Piper. So 5 and -5. So for C, pull out the negative and make a tree for 27. Pull out the negative and make a tree for 27. Guys, you're doing those three. If I think you're just sitting there, I'm going to call on you. Make a tree for -27. Okay, for time's sake, we're going to go through this and get to the stuff that's really important. So please pay attention. Here we go. Ready? So let's look at C. The biggest issue we have is there's a negative under the radical. Okay, because this is really negative, the square root of -1 times 27. This part right here, this negative square root, that's your imaginary part. So what you really have is negative, and then that -1 under there, that's your I, and you're left with the square root of 27. And I saw some really good trees as I was walking through. That'd be 3 and 9. Well, the square root of 9 is 3, so that's why you have this. So the 3's that you circle come out front. You still have this negative right here, and the I. And then what are you left with underneath? This 3. So the only thing that's different, you made a tree. The only thing that's different right here is the I. Okay, this one we've already done. Let's look at this one. Well, this one already did. Again, the negative just makes it an I. And then the square root of 49 is 7 and 7. So 7i. This one, the negative makes it an I. And then you need 2 and 24. You could do 3 and 8 or 2 and 12. 2 and 6. 2 and 3. And then again, just circling pairs. So I have a pair of 2s. And another pair of 2s. So this pulls out a 2. This pulls out a 2. 2 times 2 is 4i. That comes out. Those are the 2 2's I pulled out. And what am I left with underneath still? 3. Ideas. I is always the square root of -1. So what is I squared? Okay. Well, the square root of -1 times the square root of -1 that is going to be -1. I squared is always -1. Okay? Think about it. The square roots cancel out, right? If you have the square root of -1 squared, the square and the square root cancel out and you get -1. I cubed, well, that's I times I squared, but we said I squared was -1, so that's -I. And the fourth, okay, that's I squared times I squared, but we already said I squared is -1, so -1 times -1 is +1. So here's the deal. I squared is negative 1, I cubed is negative I, and I to the fourth is 1. Okay, so I don't know if you want to write that down again. I is the square root of negative 1, it's just I. I squared is negative 1. I cubed is negative I, and I to the fourth is 1. And that just keeps repeating. Okay? So I to the fifth, think about this. Isn't this just the same thing as I to the fourth times I to the 1, right? There's 4 of them plus 1 more. But we already know that I to the fourth is 1. So 1 times I is just I. It's a pattern and it continues. Here's how you do it. Once you get past the fourth, divide the x by 4. 6 divided by 4 is 1 with the remainder of 2. Does everybody agree that 6 divided by 4 goes in once with the remainder of 2? If your remainder is 2, then your answer is I squared. Okay, and that is the same thing as negative 1. If you have an exponent of 7, divide by 4. That's a remainder of 3. And we know that I cubed is negative I. 8 divided by 4 is 2. That means that's a remainder of 0. The remainder of 0, your answer is just 1. And the pattern will continue over and over and over again. So if I had I to the 27th, this is how I would do my homework. I would say 27 divided by 4, it goes in 6 times, okay? So 4 times 6 is 24, so what's my remainder? What's my remainder? Okay, so I went over how the first, every 4, it's the same pattern. So taking the work off again, this would be negative I, okay? I'm sorry. This would be, an I squared is negative 1. This would be negative I, and this would be 1. And then you count up 4 again, and the pattern matches. Same, same, same. All right, I to the 9th. I to the 9th is I. I to the 10th is the same as I squared, or negative 1. I to the 11th is the same as I cubed, or negative I. I to the 12th is 1. And it just keeps the pattern every 4. So here's how you cheat. You divide. So if I wanted I to the 27th, that's what it's saying. Divide whatever your remainder is by 4, and divide whatever your number is by 4, and look at the remainder. 27 divided by 4 goes in 6.75. So it had 6 holes. Let's review your long division. 4 goes into 27 6 times. 4 times 6 is 24. Subtract, and you have a remainder of 3. Take your exponent, divide it by 4, and look at your remainder. If your remainder is a 3, then your answer is going to be whatever I to the third is. So negative I. And I'm just going to leave it at that. Bottom line, the next step with this is how do we work with these numbers? We treat them like variables. We treat it like x. So if we want to add complex numbers, okay, combine like terms. Ignore the parentheses. 3 plus 5 is 8. And 2i plus negative 4. 2 plus negative 4 is negative 2. So minus 2i. Add the regular numbers, add the imaginary numbers. Okay, go ahead and do that with A and B in your group. All right, for subtracting, you do it the same way, but you distribute the negative first. So you always rewrite the problem. This will become a negative times a negative will become a positive 2. And a negative times a 6 will become a positive 6i. So that's distribute the negative. And now it says combine like terms. 7 plus 2 is 9. And negative 5 plus 6 is 1. So I have 9 plus 1i. Distribute the negative after the first minus, change all the signs, and then combine like terms. You have 1 minute to do this in your groups. Go. So, whatever is after the negative switches. So you always rewrite this. This is a negative 2 and a negative 7. And now you combine them. Use your calculator. Negative 2 plus negative 2 is negative 4. 6 plus negative 7 is negative 1i. And you can leave out the negative. Next one. The 1 and the 4 became negative. So negative 5 plus negative 1 is negative 6. And 6 plus negative 4 is positive 2. If there's a plus in the middle, add up the regular numbers, add up the i's. If there's a negative in the middle, distribute that to the second set of numbers to make it a positive problem, and then add them up. All right, lastly, we need to multiply. Step 1, write all square roots in terms of a negative number in terms of I. So I'm looking at all of these. In order to do step 1, I have to find all the ones that need to be rewritten. So these have a negative underneath it. So this negative becomes an I. What's the square root of 9? So that's 3i. This negative becomes an I, and the square root of 4 is 2. Let's see. Square root of 3 is a decimal, so this is just I, the square root of 3. And square root of 5 is a decimal, so this is just I, the square root of 5. Okay, this one, I will tell you, is negative 2i, the square root of 2, if you made a tree. And this one, the square root of 27, is just 3 times 9 and 3 times 3. So it's going to be negative 3, the square root of 3. At this point, I'm just skipping making the trees. So that's the first step. Write everything with i's. How come the negative square root of 27 doesn't have an I? Yes, question. Because there was no negative under the radical. They only get an I if there's a negative under the radical. Does that help? Anybody else? All right. Step 2. So 5, I times I is I squared. Negative 2 times 7 is negative 14. I times I is I squared. Negative 3, I times I is I squared, square root of 5. That's it. Okay, we're just doing step 2. Multiply the numbers. 3 times 2 is 6. I times I is I squared. Okay, I times I, that's I squared. And then 3 times 5 is 15. And then this last one, negative 2 times negative 3 is positive 6. We still have an I, and then 2 times 3 is 6. Okay, change all of the I squareds to negative 1. All right, so this is actually negative 1. So then if I finished it, 5 times negative 1 is negative 5. Let's see. I squared is actually negative 1. So negative 14 times negative 1 is positive 14. Okay. Does this one have an I squared? It does. I just messed it up. I times I is I squared. But that's really a negative 1. So basically you just change it. It becomes 3 the square root of 5. Because a negative times a negative is a positive. Okay? This is a negative 1. 6 times negative 1 is negative 6. I squared, that's a negative 1, the square root of 15. And this one, did it have an I squared? No, so you just leave it. We needed to do a fancier multiply. Okay, well, let's see. 3 times 5 is 15. We're going to just normal multiply. 3 times negative 4i is negative 12i. 2 times 5 is 10i. And then last but not least, 2 times negative 4 is negative 8i squared. So do it just like you normally would. But before you move on, anywhere there's an I squared becomes a negative 1. So really I have 15 minus 2i plus 10i, and then this last one, negative 8 times negative 1 makes it a positive 8. And now you can combine like terms. 15 plus 8 is 23. Negative 12 plus 10 is minus 2i. Okay? Go ahead and try A and B with your group. I'm going to put up the answer, and then we're going to start the pink paper so you're ready for the homework.